Hello students, I am Dr. Ritaba Bhattacharjee from Department of Physics, Basic Science and Humanities from Swami Vivekananda Institute of Science and Technology. Today we will be discussing a question from phase velocity and group velocity. In the year of MAKAUT odd semester 23-24, this question came. Define group velocity and phase velocity. Show that the product of group velocity and phase velocity is a constant. The marks divided is 2 plus 3. Means the two definitions is 2 and 3 marks for showing their product is a constant. A similar question came in MAKAUT 18-19 odd semester. The question is, the last part of this question is similar to this whole question. So the question is, prove that the product of phase velocity and group velocity for a de Broglie wave is equal to the square of the velocity of light. So in both cases, the last part of this and this question, they asked what is the product of group velocity and phase velocity. So let us see the answer of this first question, and then we will take the second part of the first question and this whole question together. So the definition of phase velocity is, if you are seeing a wave is traveling in a medium, in that the phase velocity is the velocity with which a wave advances in the medium. Means if this is a wave is advancing in the medium, so the velocity of this wave, say particularly this wave, we can call this as the phase velocity of this wave. So phase velocity can be written by Vp is equal to omega by k, where omega is the angular frequency, k is wave number, and the group velocity is the resultant amplitude of this group of wave. So if I see this dotted line, this is a group of wave, and if you see this dotted line, so this green dotted line is going in this way. So this is the group velocity of this group of waves. The definition is, it is the velocity with which maximum amplitude of resultant group of wave moves. Group velocity can be written as Vg is equal to d omega dk, means the first derivative of angular frequency with respect to the wave number. So this is the first part of our question of 2 marks of the MAKAUT 23-24, the first question. And the second part of this, I have to show the product of group velocity and phase velocity. And here also they asked us to show that the product is equal to square of the velocity of light. So let us see how to calculate the product. So you have already seen the phase velocity Vp is equal to omega by k. This I am giving as equation number 1. Now from Planck's hypothesis we can write E means energy is equal to h nu, where h is Planck's constant, nu is natural frequency. Now we can write E is equal to h by 2 pi into 2 pi nu. Means I am dividing with 2 pi, multiplying again with 2 pi. Why? Because I want to write this 2 pi nu in terms of omega as angular frequency equal to 2 pi into natural frequency. So I have written here omega, and h by 2 pi is written as h cross. So E is equal to h cross omega we have written here. I gave this equation as number 2. Next, this is from de Broglie's relation of matter wave. We can write lambda means wavelength is equal to Planck's constant divided by momentum of the particle. So lambda is equal to h by p, or momentum p is equal to h by lambda. Now again I will divide and multiply with 2 pi, and I will write as h by 2 pi as h cross, and 2 pi by lambda is the wave number, that is k. So I can write p momentum as h cross k, and I will give as equation number 3 for this relation. Then what I will do, I will take my equation 1, that is Vp is equal to omega by k is equal to E by h cross divided by p by h cross. Means using equation 2 and 3 in 1, we get this relation. So here h cross will cancel and Vp is equal to E by p. Now you know energy is equal to E equal to mc square, where m is the relativistic mass and momentum p is equal to, again relativistic mass I am using m, into particles velocity. Okay, so if I write this thing, I can use this equation and I can write it as Vp is equal to mc square divided by m into velocity of the particle, that is v particle. Okay, now this m is cancelling and I can write c square, Vp is equal to c square by v particle. Now very important concept, this line I have to write here. Both for relativistic case and non-relativistic case, this concept is valid. What is the concept? Group velocity of de Broglie wave equal to particle velocity. Means whether it is a relativistic particle or non-relativistic particle, the group velocity is always equal to the particle's velocity v particle. So if that is the case, I can write Vp is equal to c square by Vg, where Vg equals to v particle. Now for this relation we can write Vp, and I can take Vg in this side, so Vp into Vg is equal to c square. So this is, and c is velocity of light, which is a constant. So my question is, first question they said the product of the phase velocity and group velocity is a constant. And the second question they asked us to show the product of phase velocity and group velocity equals to the square of the velocity of light. So both the questions have the same answer, this. So this is a very important relation of the product of phase velocity and group velocity. Thank you. Now we will see a question from MAKAUT in the event semester of 23-24. They asked a very short question, but concept I need to explain you. So I am writing the question and the answer and then explanation. Phase velocity and group velocity are equal when the medium is ... Means you have to fill up the gap, and it is a question of 1 mark. So the direct answer of this fill up the gaps is when the medium is non-dispersive. Now why it is so? Let us see. Relation between phase velocity and group velocity. This is a established relation. Group velocity is equal to phase velocity minus wavelength into derivative of phase velocity with respect to wavelength. Now, if I will consider two cases, function of lambda. So it means like that the velocity depends upon the wavelength of the light. So if that is the case, then we cannot make this term equal to 0. So therefore group velocity will be greater than phase velocity from this relation. And for non-dispersive medium, waves of all wavelength move with same velocity, means all the wavelength move with same velocity. Dispersive means waves of all wavelength move with different velocity. So at the end you will not get the same result. But for non-dispersive media, the waves of all wavelength, whatever the wavelength is, they will move with the same velocity together. So as a result, the derivative of phase velocity with respect to lambda becomes equal to 0. Hence, for a non-dispersive media, if this whole term is 0, if this term is 0, then Vg is equal to Vp. So, for a non-dispersive media, Vp equal to Vg. So, two relations we have to remember. For a dispersive media, group velocity is greater than phase velocity. For a non-dispersive media, phase velocity and group velocity are equal. Thank you. Now we will be solving our equation from MAKAUT even semester 23-24. It is a numerical problem. The question is, when a photon of wavelength 6 into 10 to the power minus 10 meter strikes an electron at rest and rebounds at an angle of 150 degree to its original direction, find the velocity and wavelength of photon after collision. Marks allotted is 4. So let us solve it. This problem is related to Compton shift, means where our electron is at rest and a photon comes and strikes the electron, the photon gets scattered in one particular angle and the electron recoils at another particular angle. And in this process, the frequency of the photon with which it was traveling initially, it changes to a new frequency. And this phenomenon is known as Compton shift. So, or frequency shifting means because frequency and wavelength are associated to each other, so wavelength also changes. Now, from Compton shift's relation, we can write delta lambda, that is the shift in the wavelength of photon before collision and after collision, equals to lambda prime minus lambda, where lambda prime is the wavelength of photon after collision and lambda is the wavelength of photon before collision. Now this equal to h by m0c, where m0 is the rest mass of the electron, c is velocity of light, h is Planck's constant, into 1 minus cos phi. That is, this phi is the angle at which the photon after scattering with the electron moves. So this is the angle at which the photon moves. So now given in the question, the wavelength of the photon before collision is 6 into 10 to the power minus 10 meter, and the angle at which it gets scattered is 150 degree. Now, from this relation, we can calculate wavelength of photon after collision. Means lambda prime equals to lambda plus h by m0c into 1 minus cos phi. So I just shifted my this lambda towards this side. And I will, as usual, I will put all the values here and I will get the answer 0.0645 nanometer. Now, the second part of the question asks us, two parts are there. One is wavelength and another is velocity. Wavelength we have calculated. What is the velocity? Remember one thing, the question is about photon. So, whether photon is traveling in whatever before or after collision, the velocity of the photon never changes. So, velocity of the photon is equal to velocity of light, that is equal to 3 into 10 to the power 8 meter per second. So, this is the wavelength of the photon after collision, and the velocity of the photon after collision, before collision always remains same, 3 into 10 to the power 8 meter per second. Thank you.